And welcome to today's video. Now, today we will be talking about how to connect Alibre with Excel, right? Drive parameters straight from Excel. Now, that gives amazing potential, not just because you can do all the math in Excel, but because Excel has logic functions like if, right? Like not or whatever, Boolean mathematical operations. So the potential is endless, basically. And without further ado, let's discuss a little bit about what we will be doing today. So today we will be making a shaft with a key and a pulley, right? So here's the pulley. It is driven parametrically. In fact, I've set up all of the equations here. Let's say now it's a 24 tooth pulley now. Let's say that I want to make it a 36 one. There you go. It adjusts automatically. Or if I want to go back and make it an 18 teeth one, right? There you go. You get half the pulley. Okay. Now you saw that the bore and keyway do not update parametrically. Well, we're going to connect these to Excel. Okay. So let's start by making the parts in Alibre first, and then let's connect them to Excel. So of course, I'm going to make a new part. I'm going to call this Excel shaft. I'm going to go not too quickly, but at a normal pace. I will be doing stuff that I have shown before. So here I am just using a catalog feature to create the shaft, which will have 3 segments. And I've made this catalog feature so I can bring the segments in and then dimension them. So let's say that this is going to be a diameter of 7, right? So this is going to be this plus 2. So the first segment is going to be the bore of the pulley. The next one is going to be a step to butt up the pulley against, and the third one is going to be maybe for a bedding or something. Now these are the diameters. So the bore of 7 plus 2 millimeters for the step, and yeah, plus 2 is enough. Yeah, it should. Let's give it plus 4. And then same diameter for the next segment. First segment is going to be 10 millimeters. This is going to be, let's make the stop a square dimension, same diameter and the length. And the other piece is going to be 8. Let's make that 12. Okay, as soon as I hit OK, I get my shaft. This is the piece that the pulley will go into. This is the other one, and this is my stop. Okay, so I just made my Excel shaft. Now I want to make a key slot. So I want to make a plane. I will select the cylinder and another plane to give the direction. I don't want it there. I want the reverse one. So there we go. And now I'll sketch here. And of course, to design the key slot, I'll make a rectangle. I'll select these 2 lines, make them construction, and then finish it off with center arcs. And my pulley is going to have a total width of 1/4 of an inch. Sorry, 1/4 of an inch plus 3 millimeters, because I have a 1.5 mil shield either side. So let's say 935. So I'll just make this 9 millimeters. Okay. And then I just have the key width there. I want to center it, and in order to distribute the key equally, let's say, so this is 9, the pulley is 935. So if I make this distance 0.35 divided by 2, we should be fully defined. So this is a 2 millimeter wide key. These are usually 2 by 2, 2 width and 2 height. So I want to cut into the shaft for 1 millimeter, the other, and then it'll be 1 millimeter inside the pulley. And there you go, our shaft is ready. Okay, so let's save this. Let's save it at our GT2 pulley file. By the way, I did mention that this is a timing pulley metric GT2, so 2 millimeters of pitch. So let's save that there. Okay, now to make the key, I'll just create the assembly and make the key inside the assembly, right, as a top-down manufactured part. So let's place the shaft in the center. Right, we want it this way. Let's anchor it, and then I'm going to open up a new part, and this is the Excel key. And how am I going to make this part? Well, I'll sketch on this face, bring it in, and extrude for 2 millimeters. And that's it. Top-down design is beautiful, isn't it? Now, of course, I should be accounting for tolerances and stuff. I'm not going to worry about that now, because this is just a demonstration, right? So I have my key. Now I'm going to bring my pulley in, and I'm going to constrain this by giving it a fastener constraint there. Then I'm going to show my references and make sure that these two planes are at an angle of 0. Okay, so this is our assembly basically, right? This is what we'll be working with. Now let's go and make everything parametric with Excel. So here's an Excel file I prepared earlier, right? It has a database of values which I've taken from this PDF. It's a page from Engineer's Edge that shows key and keyway dimension, and I just printed it as a PDF. And I took these numbers, manipulated them slightly to only keep what I need, and put it into the file. And also, this starts from 6 millimeters, whereas I just made this 0 so that any bore size I select, produces a result. So this is like a database of values, and this is like the front end. Okay, and you can see that as I change these values, it updates accordingly, right? There you go. So how do we connect this to the part files in Alibre? Well, first of all, you need to install the Excel add-in if you haven't already. The help file is very, very good at giving instructions on how to install the Excel add-in, how to relink files that become unlinked. By the way, I will have these files available in the Alibre forums, but you will have to relink the Excel file if you download them. I will also have the Excel file there. If you download it, you need to relink it because the file path is different, and you can find out how in the Alibre help file. But on top of everything else, you need to go to your developer tab, which if you don't have, just right click somewhere in the ribbon, customize ribbon, check this check mark, and you'll see it. Go to the Excel add-ins, right? Not add-ins, not COM add-ins, the Excel add-ins, and you need to make sure that these 3 add-ins are inactive, right? They are unchecked. If they are checked, you need to uncheck them, click OK, and restart your Excel so that they are inactive. The reason for this is that these 3 add-ins will interfere with the Alibre add-in, and it will not be able to work. And the first time I tried to use it, they were on, and the add-in wouldn't work, and I didn't know why. So thanks to David J from the forums for that tip, because it allowed me to work with Excel and Alibre and really, really opened up new frontiers for me. Anyway, So there we are. After we've installed it, if you go to the add-ins tab here in your menu, you'll see this button, Alibre Design FX Parameters. You click it and this thing pops up. So we've got session, configuration, and some parameters here. Now, if you go to session and click here, you will see that it basically shows the parts that are currently active. Okay, now, currently, I only have this assembly showing, okay, but it recognizes that there are these parts inside the assembly, okay, so it considers them active as well. And what you see here are the parameters of every part. So in the assembly, the only value I have is from that angle constraint, okay. I don't want to change that. So let's go into the pulley and look what it does. It brings in all of the parameters from that pulley, okay. So how do I link these parameters to work with these numbers? Now you will see that, for example, I have the teeth, but in the bore I've got a function, an Excel function, right? I'm calculating the diameter, dividing it by 2 and rounding down to the nearest integer. So then I have Vlookup functions. The key data word that you see there is basically this table, right? You see that as soon as I select all of it, instead of some, a cell value or whatever, when I select all of it, it says key data here. I have named these cells as key data, okay? It's an old Excel trick. And you've got VLOOKUP functions. I have linked the shaft diameter to the pulley bore. Okay. So I want to drive now the pulley design and the shaft design and everything from this Excel spreadsheet. So how do I do it? Well, the znum parameter is already there. I just want to drive it from this cell. So I click on this parameter. It tells me that the name is znum. Type is count, not available units because it's a count variable. Cell reference. When I click on it, I get this dialog opening. I select the cell, hit OK, and then I click on modify. Now, what happened just now is that the two files are now connected, and there's no way to disconnect them, right? Or at least there's not a command to disconnect them. What you need to do, if you really need to disconnect the spreadsheet from the part file, you need to go everywhere where this variable is used, delete it and replace it with a value. And after you've done that for all instances of this variable, you will be able to delete it in the equation editor. Well, you can do all of that in the equation editor. And when you've done that for all of the linked files, the part file is going to be considered unlinked, right? But it's a process, okay? So yeah, now I also want to drive the bore from this Excel file, and I might not remember which dimension exactly the bore is. It's actually D23, but anyway, I might not remember, or I just want to have a variable named bore that is driven from this Excel spreadsheet and drives that value. So I click reset so that nothing is selected. I write in a new name and I select a type. This is distance, units. Now it needs units because the Excel file numbers are unitless, right? I just put these M in, but that doesn't give it any meaningful physical unit. So I need to tell the add-in with what units I am working with. So I'm working with millimeters. Okay. So now I'll hit the cell reference. Well, you might need to focus on the spreadsheet with one click and then select. I'll say that this is the bore that I want. Okay. And now you'll see I don't have a modify button up here. I have an add button. Okay. So this will take a while because it's opening up the part without a UI, and it's adding that variable, but here it is. Okay, the bore and the current value is 7 millimeters. If you notice, the current value for D23 is 0.7 centimeters, right? Centimeters is the default value of the modeling core in Alibre. Now, what else? The keyway width, I want it to be driven by this cell as well, right? And I want it to be a different variable. So I'll hit reset again, say key width. This is my cell reference. The type is distance, the unit is millimeters, and I'll just add it. I'll hit reset again. I want the keyway height, the height that it protrudes over the circle of the bore, to be this value, the T2 height, right? I'll reset everything again. Key T2, that's how I'm going to call it. Type distance, units, millimeters. So I'll go and select that and add it again. And there we go. And with that, I'm done with the pulley. However, I want to go in here, open it up, and use the variables that I newly created to drive this cutout. So I'll just double click on the surface and it'll open up the sketch from which it was created, that surface, right? And I want to put in bore. You see it's not throwing an error, right? It's finding that variable. So I want to put it in there. So here, D23, well, that's bore already, plus key T2, right? Yeah, the name didn't update, but this is updated, right? And I want to say that this is key width. Okay, regenerate everything, and I'm good to go. Now, I just want to show you this. If I open the equation editor, I get a error message saying that there's an external reference that's missing. And what it means is that these parameters that we just made are showing in red, and they're supposed to be missing their external reference. However, you will see later that if I change these values and update, they will update. Okay, so sometimes you get this error message and it's not true. I'm guessing that if you unlink it from a spreadsheet and then relink it, that value gets stored somewhere and it's missing that other one. In any case, now let's go back into the Excel file and do the shaft. Okay. So I happen to know that this diameter D2 value is the diameter of the shaft where the pulley goes. And we've done some equation linking of these values, if you remember. And it is now 0.7 centimeters, right? But look, I want to link it to this, which is 7, first of all. The value is 7, but it's also millimeters. How do I do that? Well, I click on the cell reference. It's null. I select it. Okay. But before I click modify, I'll need to go in and change the unit to millimeters, because if I don't do that, then the shaft will be 70 millimeters in diameter, and that's not going to work really. So we linked that again. Okay, now what else do we need to do? We need to link the key width for the slot, right? That's the only that's the only parameter that we need for the key slot, and we also need the depth, right, for the sketch of the key slot, and then you extrude cut with the depth. Okay, so let's add these values. Reset, and that is the key width. What is the cell reference? That is the cell reference. It's a distance, it's in millimeters. Let's add it. Cool. Reset. Now key depth. Okay, what is the cell reference? Well, this is the cell reference. It's a distance, it's in millimeters. Add it. Cool, we added that. Let's go change this sketch this part file so that it uses these values. Okay, so now if I go in here and say key W, it finds that variable. So if I click OK, no errors, right? This works. Yep, there you go. So now this is minus 1.05 and we want it to be minus key depth, right? There we go. That's linked as well. Let's regenerate that. Okay. And finally, we need to make our key. Now the key, the shape of it is just the slot projected into a sketch, right? So the only value that it has, the only parameter, is the height, and we need to link it there. So I'll take this parameter, which is currently in centimeters, right? And I'll say that this is the cell reference that'll drive you, but you need to be in millimeters, and modify. Okay, cool. Now, so we've pretty much done everything that we needed to do. Okay, we also need to save everything, and let's see. Okay, is this thing working? So let's bring it side by side. Let's say that I want a pulley with 36 teeth. Okay, so I plug in 36. The values change, right? Okay, the lookups, yeah, they're okay. So the values change. Nothing changed here because I need to go in and select the parts. Okay, now if you see here, current value 24, new value 36, right? Current value 7, new value 11. So it's recognized that there are changes going on. And if I hit update all, I'll take a while. And there you go. You have a new pulley. That's exciting, guys. I don't know for you, but I love this stuff. Okay, we have a new shaft. And let's get our new key, update that as well. There you go. We have a brand new assembly. Okay, let's do another example where we make a smaller one. Let's see, 14 teeth. Okay, let's do the shaft first this time. Okay, and then we'll do the key, update, and then we'll do the pulley. And I'll take a bit more time. Update. Did I click it? Update. There you go. New assembly. So guys, this is amazingly powerful, right? You can see that you can drive an entire assembly just from the Excel spreadsheet parameters, and you can have references to other spreadsheet, reference to other workbooks entirely, and they will all work, and you can all bring all of that into the port files that you have linked. And this is even available in Alibre Atom 3D. So if you want more videos like that, please subscribe or click on one of the cards. They should be over there. And if you like this video, hit the like button. If you didn't like it, hit the dislike button because I still need to know. And I hope I'll see you in the next one.